Hey, what's up guys, my name is Cherno. Welcome back to the Game Engine series. We are back with finally a new episode for this new year. I hope you guys have had an amazing break and have had some time to think about Hazel. I sure have. And to be honest, I'm very excited for this entire year because I think this is the year that we finally start actually making content with Hazel, right? So we're getting to a point where we can kind of, hopefully after a few more like important features that get implemented in the first quarter of this year, hopefully we'll be able to actually create games with Hazel and build off of there, which is going to be great because the content is going to start driving the development, and there's also a lot of exciting stuff happening with hazel-dev. So ultimately, lots of cool stuff coming this year. Everyone get excited. But today we're going to start off with this is going to be like a bit of a mini series of episodes, really. So what's happening here is basically we're going to be implementing something called mouse picking. So that basically lets us just click inside our viewport on an object and pick it and select it, right? Which is obviously a very desirable feature for an editor because we don't want to be using the scene hierarchy panel all the time. We want to just be able to just click on the thing that we want to select, and that's pretty that's pretty standard stuff, really. So there are a few ways of implementing that. I did actually have an episode, well, not really an episode, I did a live stream where I just worked out how that would even work, and I tried out some suggestions from what people were saying in the community and stuff, and ultimately played around with it and implemented a solution to this whole mouse picking problem. I've posted a live stream here on YouTube, so check it out. I'll have it linked up there. Ultimately, we're going to be kind of working in that direction because that live stream was just me working out how to actually do it in the first place, and there were of course a lot of like hacks and a lot of like, you know, me not developing a proper API and not actually writing good maintainable code because I just want to get the idea down in as short as time as possible. And that's usually how I like to work. I like to actually get the code working first and then sort it out and make it, you know, more kind of what's the right word? I guess generic maybe, or extensible to, or just essentially integrate it into the actual engine code base a little bit better. Last time though, we actually, in the Game Engine series, not the live streaming stuff, we, I'll have the video linked up there, we implemented the editor camera. So now if we hit F5 to run this, we'll be able to see that we can move around our world. And I'll show you a little bit about what I mean with the whole mouse picking thing in case you're not familiar with it. So we have this cube. It's not really a cube. It's actually left, right, and top. It's made up of 3 quads here that are just essentially entities that we have in 3D space. Now, for all intents and purposes, this is in fact in 3D space, right? This is 2D geometry. It just happens to be two-sided because we haven't because we've disabled culling, but backface culling, but this is essentially 3D, you could say 3D geometry in a 3D world, right? And obviously the camera and everything proves that. So in our 3D world, how do we then click on something to select it? So if I want to select this kind of left face over here, I want to be able to click on it, and then that will of course select it inside the scene hierarchy, display the relevant properties, display the gizmo for me so that I can actually move it around and do all the stuff that I might want to do with it. How do we implement that? So again, lots of different solutions, but what we're going to be doing is basically a little technique here where we basically rasterize the entire scene. So we run through a render pass, we rasterize the entire scene to a frame buffer, but instead of actually rasterizing and essentially writing the color value of every pixel, we're going to write the entity ID for every pixel. So in other words, if we were to look at the rasterized buffer, we would just see a bunch of entity IDs where maybe we clear it to -1. So if we click outside and we select something, it's going to be -1 and it won't be an entity. But then if we look at our entities here, they have essentially ascending IDs here, 0, 1, 2, 3. So if we click on, for example, this one, it's going to actually select this left entity. And then the way that will work is obviously these pixels will just all be set to 0. And then these pixels over here will all be set to like 1. And then the camera is 2. So all of these pixels will be set to 3. And that'll be the data that's going to be stored inside this additional texture that we basically render data to, rasterize data to. Okay, it's a little bit difficult to explain, but you'll see it in practice, and it's very simple. And then all we have to do is just simply work out a way to basically convert our mouse position into some kind of coordinate within that texture. And then all we have to do is sample a pixel at that coordinate and see what color it is. It's not really going to be a color, it's just going to be an integer that's going to be 0, 1, or 3 in this case, and then or -1. And then when we click on it, we'll pick that color, and then we'll just simply set that to be our selected entity. Again, if you want to see this if you can't wait for the series of episodes in which we implement this, the video that I have linked up there, the mouse picking one, that will actually show how I implemented this and how I actually worked through it and implemented it for the first time, because I had never done this before. I did a different way of mouse picking inside hazel-dev, and I never done this before. Up until that live stream. And that's kind of why live streaming is great, I think, and there's a lot of good stuff here. Twitch.tv/the Cherno, which I'll have linked in the description below, is where I usually stream. And it's a really good place, I think, to see kind of how I work. And if you want to interact more with the community and all of that, then definitely check that out. Okay, cool. Anyway, so that's kind of how this works. Hopefully that makes sense. And again, the live stream will clear more stuff up if you want more. But the problem is that to facilitate this, we really need to think about how we get this additional data. Now, we could have an additional render pass where we basically run through every object in our scene and then render it into that secondary buffer, or we'll say into a buffer, which we'll call our ID buffer. Now, in order to actually make that happen, though, we need to render our geometry, but then output the value for the rasterized pixel to be the entity ID. So how do we get the entity ID into our fragment shader for that? Well, we could use a uniform, right? That sounds pretty logical, I think. But the problem with that is that this isn't a piece of geometry. This isn't actually an object, or this isn't 3 objects. Right? What this is, technically, is one draw call, this whole thing, right? Because this is actually using our 2D renderer. So since it's using our 2D renderer, what's actually happening is we're streaming in these vertices into our vertex buffer dynamically, and then just drawing them all in one batch. So because that's the case, we can't set a uniform per object in this case, because again, even though this appears to be 3 different objects, it's really just one draw call, which is good because we don't want to waste 3 draws on this. This is silly, right? We can easily batch it together, but for the purposes of this color buffer, of this ID buffer, we have a little bit of a problem. Okay, so what can we do? Well, obviously we can put it into the vertex buffer itself, right? So every vertex has an ID, and that ID is essentially which object that vertex belongs to, or which entity that vertex belongs to, and that's what we're going to do. Okay, so great. So what we're going to do is, again, we're going to extend that vertex buffer layout. We're going to add this. But what about that separate pass? Does that mean that we have to recreate our entire batch, but with an additional vertex attribute? And how is that even going to work? So this already sounds very messy, and that's what I also thought that during the live stream where I worked this out for the first time anyway. So what we're going to do instead is we're not going to do an additional render pass or anything like that. We're just going to add another color buffer to another color attachment to our primary frame buffer, and just do it all in the one render pass. So at the moment we have a single render pass. It renders this entire scene, right? What we're going to do is, instead of just outputting the color, which is the buffer we're looking at right now, this is our rasterized color, we're actually going to output 2 things. So we have 2 render targets. We have one which is the color buffer, which remains untouched, but then we're going to add another one that's going to be the entity ID, and it's just going to be a buffer with a whole bunch of entity IDs, right? Because at the end of the day, it's called a color attachment, but really we're just dealing with numbers, we're just dealing with data, and these are just buffers of memory. So we're just going to create another buffer, attach it to our frame buffer, because you can do that. You can have multiple render targets, of course. And then what that's going to do is let us is going to let us not add another render pass. It's going to make it so that we can just do it all in one render pass and not be wasteful, because we don't want to run through all the objects in our scene a second time and render them to something else. If we can just do it all in one pass, it's a lot more efficient. Okay, so that being said, how do we then do that? How do we add an additional attachment to our frame buffer? And this is really where this episode is going to come in. Sorry for the very long backstory, but if we look at our current frame buffer class, so OpenGL frame buffer, that's our implementation, you can see that it's very, well, it just kind of gives you this and that's it, right? So if we walk through this roughly, it creates a frame buffer, and then we attach a color attachment to it. We attach a color buffer that's RGBA 8 and RGBA unsigned bytes. It's basically like an integer color here, right? And then it's got a depth buffer that's depth 24, stencil 8. This is very not flexible, right? We don't want every frame buffer we ever create in our engine to be exactly this specification. That doesn't make any sense, right? I mean, for one, when we do like maybe HDR rendering, we want to maybe use floating point values here. So like RGBA 16F or 32F, right? We want this to be GL float. What about if we want more than one attachment? What if we don't want any color attachments because we're doing a depth pass for our shadow mapping? And what if it's a depth pass? It doesn't need the stencil buffer. So what if I just want depth 32? Right? All of these kind of scenarios, and there are a lot, mean that we want some kind of flexible way to define exactly what our frame buffer is going to be like. So how many attachments does it have? What types of are the attachments? Do we have a depth buffer? That kind of stuff. So let's create a system for that. Now, hazel-dev, I've written something very similar for hazel-dev, right? I've written something, basically I've come up with just a nice API for us to be able to deal with this stuff, and it's kind of inspired by the API that I came up with for vertex buffers. So you can see that if I go into like render a 2D, for example, we have a little vertex buffer layout situation where we're able to just specify a whole bunch of types, right, for all of our attributes, and then a name. Now, the name doesn't really do much, and we actually discussed this in the earlier stream that I had today. I had another stream today, which I had to abandon halfway through because I had to do some stuff. But ultimately, we talked about this a bit, where these names are usually more they more apply to like attribute semantics and stuff in HLSL, because this kind of system is something that I wrote for Sparky. And Sparky supports DirectX and OpenGL. Sparky is an old engine that I wrote about 6 years ago. So these names don't really do anything for OpenGL. They do for DirectX. But anyway, the point is though, we have a nice little list of attributes. So why not do the same for these attachments, right? Why not be able to specify a list of attachments? And I'll show you what the API looks like. So this is hazel-dev. This is our scene renderer, which basically creates a whole bunch of different like render passes and stuff like that. And so it obviously has this little frame buffer specification, and we also create a whole bunch of frame buffers. So the way that we create frame buffers is we pass in a specification, right? And then this specification has a list of attachments. And you can see that in this case, this is our geometry pass. So this is like our main kind of pass where we actually render all of the objects in the scene. And of course, this in general, if you haven't seen hazel-dev, I'll link a video up there. But hazel-dev is obviously a lot more advanced than what we have inside Hazel at the moment. We're doing like 3D rendering and all of that. And this scene has like shadows and a whole bunch of different render passes and it's HDR and everything. So the way that it works is we basically define this list of attachments. So you can see that in this case, for the geometry frame buffer, we have an RGBA 16F buffer, an RGBA 16F buffer, and a depth buffer, right? So what we're actually doing here is we're saying, I want 2 color buffers, I want them to be this type, and I want a depth buffer. Pretty simple, right? And then there's some other options for like multi-sampling and the clear color, but that's kind of it. Or look at this compositing buffer, right? This is kind of our main kind of scene composite buffer. So this is an RGBA 8, because obviously we're going to be displaying it on a 8-bit display most likely. So we're outputting just an RGBA 8 kind of, we're rendering the compositing pass to an RGBA 8 texture, and we're doing the tone mapping and all of that stuff. And you can see there's no depth buffer because we don't need one. Another good example is the shadow map pass, right? So the shadow map pass, we create like a 4K texture here, and you can see it's just got that depth 32F because we don't need any stencil buffers, we don't need any color buffers, it just needs to be a depth buffer, and that's all it is, right? And we've also got some other parameters, in this case like no resize, because we obviously don't want the texture to scale along with the window resizing, whereas these ones we do because they're the main kind of viewport buffers. So anyway, that's how it works inside hazel-dev. And someone also said that what if we want certain texture filtering, right? So what if we want to have you know, linear filtering or nearest filtering, or what about like wrap modes like clamp and all of that stuff? Repeat, how do we set that up? Well, the thing is, this list of attachments is not just a bunch of texture formats, right? What it actually is frame frame buffer attachment specification, the way I've implemented it, which is this, which has an initializer list of frame and stores a vector of frame buffer texture specification, which is this, right? Which, I added this during the last live stream, it's not really implemented, but anyway, which you can see is that texture format, and we have a constructor which lets us implicitly construct it just by using the texture format, which is one of these, right? But we can also add wrap and stuff to it, which means that if we wanted to not have the default wrap of like clamp or whatever, or maybe we wanted some kind of filtering, we can just add it here, where we can just do like, what is it, texture wrap, repeat or something like that if we for some reason wanted it. And if we had a constructor for that, that would work, right? So we can kind of add more detail if we want to, but if not, we just rely on that implicit constructor. And then we can literally just specify a list of formats and we get all of our frame buffers and then obviously all of our texture attachments for the frame buffer. So and then obviously the frame buffer has to go through that list, and then when it gets invalidated and actually go through and create all of these textures. So that's how hazel-dev works. I really like this system. I've been using it for the past few months. Yeah, I think it's really clean and it works really well. All right, cool. So let's pop in over to our code and start implementing something like this. So again, the way that I like doing this, I don't even know where we create the frame buffer, to be honest. So let's go ahead and, should we search for that? No, let's go back to edit a layer. And then I want to see, do we do it here? I guess the scene, do we have a scene renderer? We don't have a scene renderer yet. Maybe the scene just does it, or not. How on earth do we render anything? Does the renderer do it? How does rendering work in Hazel? I'm serious, where on earth do we create that frame buffer? Frame buffer. Let's go ahead and find it. I have not pre-written the code for this. I will be referring to hazel-dev, to hazel-dev's code, but this specific code I haven't written for this episode. Okay, so here we go. Oh, okay, it is inside edit a layer. So we create a frame buffer here, and then I think we, yeah, and that's essentially, that's the frame buffer that we eventually display in the viewport as well. And then that's the one that we resize here and that we bind before rendering. Okay, cool. Okay, so that's fine. So when we create this frame buffer, right, which happens over here, you can see we actually already have that specification here, but this specification doesn't have, it's got frame buffer format and all of that stuff. And I don't even remember talking about this stuff, but ultimately what it doesn't have is, again, that little list that we're going to be discussing today, which is going to be a list of texture formats. So the first thing I want to do is specify a enum class, and this is going to be our frame buffer texture format. Now, why am I not using texture formats? And that was a good point, I think, that I thought about. So textures don't have formats at the moment, which is not good. But I think I wanted to keep this separate, just because like the way that it works is these aren't necessarily standard textures. So we also have things like depth and stencil, and those aren't really like textures that you would ever create as part of the texture API, but they are things that you would want as part of the frame buffer API. So there is a bit of a difference. Okay, so I'm literally just going to copy some of these formats and stuff from hazel-dev, but I'm not going to go ahead and implement all of this stuff right here, right? So in fact, I'm not going to add a number to these things. So color and depth stencil, depth 24, stencil 8. So this is the stuff that we're using at the moment, and then I'll set a default as well. So the reason I'm doing this is just because if we explicitly want it to be this, we'll do that, but otherwise we will just specify depth and it should sort it out for us. Okay, so I haven't really done anything new here, right? All I've done is I've added, and the idea here is that when we do add, like for example, when we do have the need for like RGBA16F, we'll just add it here. So I don't want to like whoa. Nice one. So I don't want to like overcomplicate anything now because we definitely don't need those formats just yet. I will add them as required. Okay, so now the next thing is we create a struct called framebuffer texture specification, right? And this is the thing that actually contains the specification for a texture. So these are just the formats, right? This is the actual physical specification of a texture. So the format, the wrap, and the filtering, right? So we'll have, I'll make the constructor Framebuffer texture specification. We'll just have a default constructor. And then we'll have a constructor that takes in one of these texture formats. And this is going to be an easy one. All this is going to do is set the texture format, which we don't have yet, to be a format, right? And then we'll have Framebuffer texture format, texture format. Okay, and then again, I'll leave it to do here because we probably won't get to this today. This will just be the beginnings because I spent quite a long time. And there's like sub-gifting and stuff going on. I'll deal with you later stream. Sorry, recording an episode. I should get that stuff to appear. But anyway, yeah, so we'll deal with this stuff a little bit later, maybe in the next episode, because I do want to complete this to an extent. But I don't want to waste too much time here, and I want you guys to get the kind of main idea, since this is more of an introduction. Okay, so we've got this. So this represents each individual texture that we add to our frame buffer. And then finally, we need the collection of them. We could kind of add it here, but I don't want to because we want to have some extra stuff on top of this. And you'll see what I mean in a minute. So this is frame buffer attachment specification. And specifically, this is the collective frame buffer attachment, right? So these are all of them. And the way that this kind of manifests itself is that it has a list, a vector of these textures, and we call these attachments. And then I'll go ahead and create like a default constructor as usual, just to make sure that we have that, because we're going to also add a constructor that takes in an initializer list of these texture specifications. So this is what lets us kind of write it. This is very similar, by the way, to what I did with the vertex buffer layout. So if you're confused, or if you want to see another example of this general, like what is an initializer list, how does this work? If you go to vertex buffer, then we also have, you can see a buffer layout with an initializer list of elements. Maybe we don't need to do a const reference, I'm not sure. But then again, that was a list of enums. This is a list of classes, which I mean, you know, okay, whatever. We won't add a const reference. Never know these days when you want your const reference and when you don't. But anyway, and we'll have a bunch of attachments here, which we'll just set like this. So we'll construct the vector with the attachments, with the initialized list. That's it, right? And then obviously the last thing we have to do is have the actual attachments here. So I call these attachments as well. These are just our attachments. So now the cool thing is, this whole thing changes, right? Now what we do is we say fbspec.attachments equals, and we specify our attachments. So frame buffer texture format, RGBA 8, and then frame buffer texture format, depth, just depth, right? We don't care, we just want a default depth buffer, right? Now we're creating this. So this obviously looks better because for one, by creating a frame buffer, we're aware of what on earth it is. Before it was like implicitly implied, that's funny, that it would be this, which is just ridiculous. We want to actually see that here. I mean, it's fine to have a default potentially, but I like to be quite verbose with my programming, I guess. I like to actually clearly specify what is happening, because otherwise it's just a mess, I think. But anyway, so we have that, and now we need to actually make it do something. So if we go back to OpenGL frame buffer, this is all great, but obviously we haven't changed any of the code. It still kind of remains as is. So our next step is going to be to change this around so that we can actually create all the attachments necessary. So when invalidate happens, which might be on resize, obviously resize calls invalidate, as you can see, we create the frame buffers. That's fine. This is the attachment specific stuff. So attachments. So from here all the way to here, we create a color buffer and a depth buffer and attach them. So let's go ahead and change this. So first of all, if and this is actually something that we need to do. I think I did them somewhere here. We basically need to. Where did I do this? Okay, so one thing that we have that's a bit of an advantage. So one of the things we need to do is basically easily sort our attachments into two categories: depth and color, right? Because at the moment we have a list of attachments, but some of them are color, some of them are depth, and for some reason I decided to handle them separately. right? So the way that I did this was, and the thing that's interesting here is that inside invalidate, invalidate is basically, I haven't talked much about this, I think, but invalidate is an interesting function because invalidate means that something has changed inside our frame buffer and it needs to be, it's no longer valid, right? So a good example is the width and height. Now, whether or not specification width and height should change, a bit of a different question, because maybe we want to maintain the original width and height no matter what, no matter if it gets resized, so we might deal with that later. But there's two ways you could go about this. You could assume that the specification that a frame buffer gets created with is set in stone, meaning that if you want a different spec suddenly, create a new frame buffer. This frame buffer is going down with the ship. It has this spec, right? Not in terms of width and height, because that's somewhat arbitrary, right? Depends what it's for, but it's somewhat arbitrary, we'll say. But in terms of the rest of the specifications, such as like, hey, is this multi-sampled? Is this a swap chain target? Is it, what attachments does it have? You could say that's set in stone. And again, you don't have to, but if you do, it means that inside the constructor itself, you can, for example, sort out the attachments into those categories, right? And I think that's what I'm going to do. So I could do it in invalidate, but the thing is, I don't necessarily think it's work that we need to do every time we resize the frame buffer, because we already should know what the attachments are. They're not going to change just because our frame buffer gets resized. That's why some people have, like, you could have a resize function instead of invalidate, or resize and invalidate, but invalidate to me just means recreate the whole thing. So that's what we'll do here. So what I've done in hazel-dev and what I'll do here is I'm basically going to go through all of the attachments, right? Which is what this is. And I'm going to check to see if it's a depth format. And if it is, I'm going to put it into my color attachments, otherwise into my depth attachments. So the way that I did this was I basically had two little piles inside here. I had a vector, and we'll assume that we have one depth buffer. I don't even know if you can have two. I'm not sure if I've ever done that before. Usually you have one depth buffer. We'll do frame buffer texture format, and these are going to be our color attachment formats. So then you can see we've got a vector of them, and then I'm just going to have a depth buffer format. Depth buffer, depth attachment, I'll call it format. And this is also why I had that frame buffer none thing, because I want to have a default, I want to have a, like, an invalid state, right? So I want to have, like, well, it's not that it's invalid, it's just that it's empty. I want to have an empty state. I want to have a depth buffer format that isn't really real. And that way, obviously, I can check to see if that's none or not. And if it's none, then it doesn't exist and I have no depth buffer. So what I'll do here, and I wrote a little function inside hazel-dev called isDepthFormat, which I just wrote inside here. So let's just write it here for now. Static bool isDepthFormat, frame buffer texture format. And then in hazel-dev, this does something very simple. And for us, it'll be even simpler. All it has to do is basically check to see, is it this? This is the only depth format we have at the moment, just one. And so we can just switch on format. The reason I'm doing a switch on an if is because we'll add more formats later, like depth 32F. And so I don't want to, I'm just kind of allowing for that, I guess. Okay, so case frame buffer texture format. Okay. All right, so there we go. So we return true if it's that, and then otherwise we return false. Pretty simple stuff. And in fact, I'm going to put this into a namespace called utils, because it's, we might move it out of this class, we'll see. And so all I'm going to do is over here, I'm going to check to see if, so I'll do the opposite case first. So if utils is depth format, and then format. So if it's not a depth format, I'll add it to color attachment, just because it's probably, we're probably only going to have one depth buffer, and it just makes more sense this way. So we'll do, I guess we can do in place back. I don't think it'll matter too much in this case. Else. And this format should be, I think we should do format texture format. Else we'll set our depth attachment. And again, we should only have one. It's technically possible to put in both. I don't know if we want to protect against that, but otherwise we'll set depth attachment format. So what this is doing is upon construction, it's just sorting out that list, right? And it's seeing, hey, what's your situation with the color and depth? And unfortunately we've got errors and stuff, which is a little annoying. All right, let's sort this out quickly. That was annoying. So it's not happy with this. Format.texture format is what we actually want to in place. Right, so what we should see at this point in time is color attachment we have 1, RGBA 8, and depth attachment we have 1, depth 24 stencil 8. So it's just sorted it into basically one of 2 buckets. Okay, cool. So inside invalidate now, what do? Well, we have to go through all of our attachments and set them up. So for auto, and what is this exactly? This is a Framebuffer texture format. So these are just formats, right? So for auto format inside, and the thing is, I did it this way, but probably shouldn't have done it exactly this way, because what about different filtering modes? Why did I do it this way inside hazel-dev? Probably just for fun, because I like to break things. Let's instead actually take in this, I think. So Framebuffer texture specification, right? Depth buffer probably not too important, although it might be. Let's do this instead. So these are our color attachment specs and depth attachment spec. And I'm doing this because I guess we can have a default one, because by default, we haven't set this up actually, we should have. By default, our texture format, we should set to none, right? This will just make sure that if we hit the default constructor, it will set the texture format to none, and then we can check for that to see if, for example, the depth buffer doesn't exist, right? So this we just do that to this, right? Depth attachment specs. I like to write it out. So color attachment specification, depth attachment specification. Okay. Yep, and we check the format. Okay, spec. That's better. That's an improvement, and I'll probably try and merge that into hazel-dev. Okay, so we go through all of these specs, right? So for auto spec, don't know about copying it, but we don't need to. Color attachment specifications. And then basically what we want to do here is, for one, see exactly what format it is, and then based on the format, we probably want to create it, right? So the way that I do it in hazel-dev is I have another utility function called create textures. And I think this basically just creates a texture with the given target. So this is based on whether or not it's multi-sampled. We're not really dealing with multi-sampling at the moment, but what I do here is a number of things actually, and I think that we might want to have, yeah, okay. This gets a little bit complicated in order to do it in a scalable way, so let's do it this way. So first of all, we'll check to see if we have a color attachment. And if we have a color attachment, right, meaning that we actually just have any color attachments whatsoever, I'm going to, first of all, get the actual color attachments, which we don't have at the moment, and they're going to be renderer IDs, right? So we'll create a vector of, so we have a vector for specifications, but now we're going to have a vector of renderer IDs, right? And is renderer ID not a thing? You're on 32T then, it is. And this is going to be our color attachments. And then we're going to have one of these for our depth attachment. Okay, buckle in, because this episode is about to take off. It's going to be a lot of work in a minute. So, if that's the case, and we'll have to rewrite this anyway, but whatever. If this is the case, then the first thing I want to do is take our color attachments and resize them to the right size, right? Just to avoid unnecessary allocation inside our vector. So now that we've now that we've resized them, let's go ahead and write another utility function called create textures, right? And again, this will deal with multi-sampling and stuff, but not at the moment. So we'll tell it to create maybe with specification. Well, I think it just needs to be either true or false. So we'll add a little bool multi-sample equals specification dot samples greater than 1, and then we'll have a little boolean for whether or not this is a multi-sample texture. And then we will, so we're creating the textures, and I guess we just need the actual data and size because that's what OpenGL wants. So we'll do color attachments dot data. I could have just passed them in, but anyway, color attachments dot size. You'll see what this ends up being in a minute. So what this is going to be is basically static void create textures bool multi-sampled. And then we're going to have our uint 32t, which is really just a GL uint. Probably should use OpenGL's type, but do add ID and then count. So that's going to be where it stores the outputs. And then we do GL create textures. We'll run another function called texture target with multi-sampled, and then we do oh, what? So at the moment I just did that, did I? That's a bit weird. That looks like a bug. Anyway, it should be count and out ID, but for some reason I just have one here inside hazel-dev. Weird. Okay, whatever. So static void, static GL enum texture target. Very easy, simple function, just returns GL texture 2D multi-sample or GL texture 2D. So I guess I am implementing multi-sampling in a way here. Oh well. Okay, so that looks good to me for now. While we're here, we might as well add some of the other utilities that we'll need, such as bind texture. The reason I'm doing this is because I didn't want to talk about multi-sampling today, but sometimes it's hard to copy like half of hazel-dev's code. But ultimately, the reason we're doing this is because the texture target, right? So what we bind here, and yeah, if we use direct state access, we don't need any of this. Anyway, we'll write it like this for now because that's consistent with the rest of our API. But the texture target is going to be the GL texture 2D or GL texture 2D multi-sample, depending on whether or not it's multi-sampled. And so because we don't know that, you know, instead of doing branches and switching everywhere, we just have some convenience functions that do that for us. Okay. I'll call, yeah, that's fine. Okay, so we have these for now. And again, that just means that when we actually go through this, if we have any color attachments, we'll fill this color attachments vector with, because we've resized it, we'll actually just write into the data and we'll generate a whole bunch of OpenGL IDs for each color attachment all in one go, which is good. Okay, so that's what's happening there. Hopefully that makes sense. Now, the next step is going to be to actually create the textures. So we've created the, we've created the textures, but we haven't specified what format they're going to be or anything like that. We haven't allocated the memory for them, which is what we need to do. So we have to go through, I'll leave that, in I equals 0. And we'll do size t. I equals 0, oh my goodness me. I is less than specification size, I plus plus. And we can probably just use color attachment size. It doesn't really matter, they should be the same. Utils bind texture, and again, multi-sample, so that we support that. And then we're going to bind color attachments I. So color attachments, remember, they're our render IDs, right? So we're binding color attachments I. I don't really want to call it color attachment renderer IDs, so I'm leaving it as that. But obviously, if you look at it and you see that it's uints, you should be able to tell. Okay, so next step is to basically create what we need based on the format. So we'll do switch on color attachment specifications I, which remember these match up. So color attachments I and color attachment specifications I match up because we've created, well, they're going to be the same size, and we are obviously going through them from 0 to the end. So we basically check to see the texture format of the current color attachment specification, and if it is a Framebuffer texture format RGBA8, it's basically going to be either, it has to be that actually at this point in time. That's the only color specification we actually have. So at this point, we'll call another utility function called attach color texture. We'll give it the renderer ID. We'll give it the amount of samples. We'll give it GL RGBA8, and of course this is coming from hazel-dev, by the way, patreon.com/thecherno if you want to get access to the complete source code of my 3D version of Hazel. Specification width, specification height, and I, which is the index. All right, now let's go ahead and implement this function. Not gonna be that bad, I promise. So static void attach. This is really the big one, right? And again, we need to expand this and include more formats in the future, but that's really all we'll be expanding. Everything else should just be scalable. So height and index. So again, bool multi-sampled, quickly create one of these, because we actually need the amount of samples as well as whether or not it's multi-sampled. So if it's multi-sampled, then we'll do GL text image 2D multi-sample, GL texture 2D multi-sample, samples, format with height, GL false. Okay. Read the documentation if you don't understand this, but it's very similar to normal text image, except we just supply the number of samples, right? Internal format's going to be RGBA8, as we passed in here, over here, right? Width height is self-explanatory, and this is just fixed sample locations. We just set that to false in most cases, really. But again, consult the documentation. Okay, so GL text image 2D. Otherwise, so if it's not multi-sampled, which is currently we don't really deal with multi-sample textures. It'll be the same except we're on a different function. So not text image 2D multi-sample, just text image 2D, and we pass in a different target. And then from here, level 0 internal format is going to be format. Width height is going to be width height. Border is 0. Now, format is the access format, which we'll keep as GL-RGBA. This is, so we have two formats, internal format, which is how OpenGL stores the data, and then format, which is how we access the data. So, or like the incoming data. So, sorry, yeah, format is the incoming data, right? Incoming data and then the storage type. So, yeah, we'll just leave this as GL-RGBA and GL unsigned byte for now. Right, we'll have to have a conversion function because this might be like float or int in the future. But for now, we'll leave that as is, and then we'll just do null pointer, right? Now at this point, we need to set all the filtering stuff, right? So the filtering and the wrap, which we should have just taken in the spec, right? Because that has the format anyway, but this is an OpenGL format now, right? So yeah. Okay, so again, the filtering and stuff we said we do later. Filtering, well, yeah, we don't even need to write this. Because what we'll do is we'll go through GL text parameter I. We'll do texture target, because again, this well, no, this won't be multi-sample, because, oh, this is a bug inside Hazel as well. Wait, what? How does that work? Oh, apparently you don't need to set. That's weird, isn't it? I might have to take a look at this later. But basically we'll do texture target multi-sampled. In this case, it'll always be false though, so is it really probably no point running that. I'm not sure why I'm not setting parameter I for. Well, I'm not setting these like parameters for multi-sample textures. Maybe because different ones apply or something. But like, yeah, I guess minification magnification for multi-sampling is different. Okay, whatever. And then we'll do wrap, GL texture wrap. So this, you know, we'll do RST, clamp to edge. So, basically, you, like, at the moment we're just setting this to linear and clamp to edge, but you know, depending on a lot of things, including, well, this is a Framebuffer, so I'm not sure about mipmaps and stuff, but yeah, that could be useful. Anyway, this stuff will be set from the Framebuffer specification in the future. That's kind of it. Again, I said it wouldn't be too difficult. The next thing we need to do, though, So if we had 2 of these, it would work, right? It would just add it to 2 different things. Now, why do we have the index though? Because the index so far has been useless. Was that just something that I never implemented? Oh, whoops, I didn't attach it. Good thing I went back. So GL Framebuffer texture 2D, GL Framebuffer, right? This is the attachment code. I think we've already got one of these here, right? So let's copy it. Let's pop it in. Except this time we're going to do color attachment 0 plus index, right? And then the ID is obviously going to be ID. And that's it. And this is going to be going to go through texture target. All right. So that's it. We've created our textures. We've allocated memory for them, right? And then we've attached them to our frame buffer at the correct index. And that's what this does. And so obviously if we run this twice, we would have created 2 textures that are going to be attached at color attachment 0 and color attachment 1, which is great. All right, so next stop is the depth attachment, right? So again, it's possible to not have them, so we need to check it first. So, but it's not a vector, so we can do if depth attachment specification doesn't equal, texture format doesn't equal none, then it's valid, right? So we have to basically create a texture, except this time we'll create 1, and it will go into, oh, whoops, 1 goes here. And it will go into the depth attachment slot. And then we'll do, and we'll leave multi-sample there. Then we'll bind it, again, whether or not it's multi-sampled, and obviously depth attachment is what we're binding. And then we need to basically do a switch on the format. So very similar to this, except there's no for loop because there's just one of these. So we do depth attachment specification dot texture format. Again, in this case, we only have depth 24 stencil 8. It's possible to have other ones like depth 32f is another popular one. So we'll set up our code for that. So attach depth texture. This is going to be a different one. And we'll pass in the depth attachment. We'll pass in the number of samples, right? Which I thought we had, but we didn't. It's inside here. And then for this, in this case, depth 24 stencil 8. And then what else did I have? GL depth stencil attachment, because it's possible again to just have a depth attachment. So we have to specify which one. And this one does contain a stencil buffer. And then m specification dot width, m specification dot height. That's it. Okay, so what is this all about? So this is again going to be very similar to what we had before, which was this. So we'll copy and paste this. Attach a depth texture. So ID samples format will add something else though called attachment type with height, and then we don't need an index. So multi-sampling still applies to depth buffers. That's fine. And then over here, the difference is, well, we'll do GL text storage 2D. Few differences, and I don't really want to get into this too much. It should work in all cases though, I think. And then what do we have? Level. So one level internal format is going to be format, and then we just have width and height. We can leave our parameters. And then finally, Framebuffer texture, this remains the same, except the attachment is now the attachment type. So either depth attachment or depth stencil attachment. And then we have the multi-sampled, and then the ID, and then the 0 for the level in this case. Okay, that's it. I think that is actually the end finally. So yeah, lots of code here. I suggest you guys, I'll commit this obviously after the episode. I suggest you read it and maybe go, if you really don't understand how it works. I mean, it's pretty simple. It's just a lot of actual code, right? But we've basically just organized it in a way that is completely responsive to like a dynamic kind of collection of specifications that it can use to actually create these physical OpenGL objects, basically, okay? So that's how that works. Now, finally, though, what we need to do is we basically need to check to see if the color attachment size is greater than 1. Because if it is, then there's something else that we have to do. So first of all, we'll assume that for now, we only support a maximum of 4 color attachments because the next block of code is only going to support 4. So we'll make sure that we have no more than 4 color attachments. And then what I'm going to do is define our draw buffers. This is something you need to do on OpenGL if you actually want to draw to more than one render target. So basically what these are these kind of color attachments that we define inside a list, inside a little array like this. And then we just do GL draw buffers and we're basically enabling them. So for the amount that we have, and we've got an array that defines 4, but we don't have to use all 4. And that's what this is doing. So we basically say how many do we have here? Well, what am I trying to do? Control-Shift space. How many do we have here? We have 4. And then what are the actual buffers? So the buffers are buffers. Okay? And that's it. So that just enables them for rendering. Otherwise, if it's only a depth pass, and I don't know if this is strictly necessary, but basically else if m color attachments size is 0, right? So I guess we can do color attachments empty. Then GL draw buffer, GL none. Only depth pass. This might be like an optimization thing, maybe. Okay. And again, this would be used for like just a depth pass for things like shadow mapping. Okay. That is it, I think. So we don't need any of this, right? We've got that inside our other functions. We should still check to see if it's complete or not. Obviously, it's very important stuff. But that is it, and then we can unbind it to make sure we don't accidentally render to it without meaning to. Wow. So when we invalidate it, another thing we should do, by the way, is make sure we clear everything, because if the specification changes, I mean, the thing is it probably won't. Well, yeah, because what we're doing here, obviously, is we're going through everything again, and we're resizing stuff. So I think that you probably would want to clear this, because just the actual color attachments, not the specification necessarily, just the renderer IDs, because you've just deleted them. They're now pointing to invalid IDs, so let's get rid of that, and then let's set depth attachment to 0 as well. Okay, and that really is it, I think. When we bind it and when we do, this stuff looks great to me as well. Oh, yeah, this is something that needs to be addressed. So color attachment, depth attachment. Oh, we have another function called depth attachments. Great. Great. I'll delete this. So we don't have a color attachment anymore. Let's go ahead. Let's go through deleting all of this stuff. So delete textures now just takes in all of them at once. So color attachment. Oh, someone just subscribed. Oh, it does show up on the recordings. I didn't know it does. Okay, good. Cool, Amur, thank you for your subscription. Also previously, Elfix as well, and Sibia gifting subs as well. Thank you to gifting subs to Royal. Anyway, so much stuff, so much stuff to catch up on. But it's been a long episode. What are we at right now? 53 minutes. Incredible. Telling you guys, game engines are a serious business. I don't know what I'm gonna do with these episodes. Okay, so we'll go through all of them. And then color attachment specifications data, right? So this just deletes them all in one go, basically. And then the depth attachment we can clear as necessary. I don't really know what happens if you give it 0. Will it just not delete it? I guess not, because I don't think hazel-dev crashes because of this. So, and sorry, this is color attachments, not the specifications. So let's do that here. So we just delete all of them. And I guess if it's 0, it's not going to do anything. And I guess if that's 0, maybe it won't delete it. I don't know. If anything, we can wrap it in an if statement, obviously, and just only delete it if it's actually valid, if it's a thing. Oh, I think that's it. Let's just run it. Maybe everything will work. It should look exactly the same. It's already failing to compile. Color attachment, undeclared identifier. Get color attachment render ID. Okay, well, this is a bit controversial because which one are you talking about? Index, it's 0. Return color attachments, index, and core set, to make sure that index is less than color attachment size. Okay. We've changed the signature of this. Let's go back. F5. So it should work the same. We had a default parameter of 0. Okay, so far so good. So we didn't get the assertion or anything, and we see our pink cube is normal, right? So what we should be able to do now, right, is essentially add in potentially another one of these, right? And now our frame buffer should actually have 2 attachments. I'm not sure if this will work. I mean, I guess it should. Right? And then we should be able to actually draw to that if we so wanted to, right? In fact, should we test this out? I guess we should test this out. So I think what I can basically do, right? We've already gone this far, right? So if I go to the shader, let's go ahead and just do layout location 1, red, color 2, we'll say. And then we'll just say color 2 equals just red, right? Just red. Maybe let's do a nicer red. I don't want to just completely ruin everyone's eyes with a full red. Just something like this, right? Nice little red. And then what we'll do, so this should, ideally everything should work. We'll still see the pink cube, right? But then what I'm going to do is when I actually when I actually draw the viewport, what I'm going to try and do is, you can see I get the texture ID, give it to ImGUI. What if we get index 1? So that's the second color buffer. So this should be red, if everything has worked correctly. And I believe it should have. There you go. Okay, so you can see that what we've got now is a shader that's rendering to 2 targets. And we're able to easily create that using a pretty nice specification API, I think. That's my personal opinion. And then obviously we're able to render to it perfectly well and read back from it perfectly well as well. Okay, so that is the end of this extremely long episode. Hope you guys enjoyed it. If you did, if you're watching on YouTube, don't forget to hit the like button and subscribe. You can also help support the series by going to patreon.com/theCherno, which I'll have a link in the description below to as well, where you can get access to all of the hazel-dev source code that led up to what you see here. You know, we've had this API for a while, and obviously we're actually using it to do stuff like shadow mapping and you know, various other passes and compositing and whatever. So yeah, and then obviously you'll be helping to support the general game engine series and my YouTube channel and everything here, and would not be possible without all of you guys. So really, I'm thankful to everyone who subscribes on Twitch and to everyone who also supports on YouTube. Thank you guys for watching. Don't forget to follow the stream if you want to catch more of these live streams, because this is streamed live, and I will see you next time. Goodbye.